All right, the next one we have is a t-shirt, Hide Your Books, the Bibliomaniac has arrived, and Shmoo Group mousepad. So the trivia question for this is, in trigonometry, what does the acronym SOHCAHTOA stand for?
Sine over cosine, opposite over adjacent. And what is it over
Well, not quite. There's a few of the words were... All right, with the hand up in the air. All right, very good, sure. Come have a t-shirt and a mousepad. I guess you don't need the book that we just gave away. All right, before we get started, a few small announcements in addition to the stuff Bruce just talked about. We have no more wristbands for the party tonight. If you are not going, feel free to find somebody that is going. There are still a bunch of people that want to go, but we just don't have enough wristbands to let everybody in. So if you're not going, find somebody. There's a lot of people that want them. If you are interested in buying any of our swag from past years, feel free, head up to the registration desk. We have some free stickers to give away, as well as some of the past bags. But for now, how to be an RSol?
RSol, yeah.
An effective bug hunting in Solaris. And so please give a warm welcome to Matt Hillman.
Can everybody hear me, first of all? Yes? I'll take that as a yes. I can't hear anyone saying no. Okay, so I've been working on owning Solaris, but then I got a bit distracted, and my work took me in a direction that I wasn't originally intending. So my name is Matt Hillman, and I work for MWR Infosecurity in the UK. And you can find all of the research that we do, including what I'm talking about today, at the lab's website, the URL you see on the screen. I'm also a member of NMRC, and I think I'm contractually obliged by my membership in this group to have Gas Mask Girl in my presentations at least once. So there she is. Okay, so I'm going to start off talking about how I got to where I am. As I said, I kind of went in a different direction to what I was originally intending, and I think it's important to understand why I was doing what I was doing and why I implemented it in the way that I did. I'll then talk about what RSol is and how it operates, and then show you some demos. And I should say the demos are not going to be quite as I had originally intended. I had intended to get a Spark machine with Solaris running here that I would be able to show you it running on, and unfortunately that did not pan out. Don't buy from eBay. But yeah, and then I'll talk about where I'm going to go with this in the future, because I've got quite a lot of stuff that I want to do in the future with this as well. So, how I got here. I wanted to look at Solaris security. I wanted to start finding bugs, fuzzing, and so on. And I realized that there wasn't really the tool chain, at least publicly, on Solaris that there is on other popular platforms in order to do this. So I started initially very quickly looking at Sully and thinking, let's just get something going really quickly and see what we can find, and realizing that, well, there's not a process monitor for Solaris that you can use in order to get good information about what's happening with your fuzz cases. So I looked at, and I should say as well, I hadn't done anything with Solaris before, so this was also me learning Solaris at the same time. So I started looking at the options that I had that I could use to enhance this rather than just waiting for it to die and seeing what had happened. Obviously, I could use core files, kind of simplistic. I could mimic what the process monitor does in Sully in Windows, which is basically it acts as a debugger, attaches to the program that you're fuzzing, and attempts to glean information about what's happening. And to do that, you would use on Solaris the proc file system, which is how you attach as a debugger in Solaris. And then there was DTrace. DTrace. This was a new thing to me. I'd seen some talks about it before. And DTrace is quite interesting. For those that don't know, DTrace is a dynamic tracing framework available in Solaris, and it's available on some other platforms as well now. And it's very different to attaching as a debugger. You basically lay probes within the system at different levels. and it's implemented as a kernel feature, so it operates quite differently. The goodness that you get from DTrace, there's been a lot of work done before. ReTrace has been presented several times before that makes use of DTrace to aid you in reverse engineering or whatever you're doing. And you can trace at a wide range of levels. So you can trace at the source level, you can trace at the protocol level, you can trace at the instruction level, and you can do all of these things at the same time, which is obviously very useful. I've said hit probes are queued, so when you're placing a probe and you hit that probe, it's actually placed in a queue, which DTrace will then check at sort of comfortable intervals. And this kind of gives you the performance increase when you're actually running the process, rather than a breakpoint that you might set in a debugger, where the process actually has to physically stop while the debugger does its thing. These are queued, and then DTrace will check them and run the actions. So you get some performance increase there. And you can have highly specific conditions on your probe, so you can say you want the program counter to be equal to this value at this particular point in the program or something. And this has been used in ReTrace in the work that they did to kind of monitor for stack overflows and monitor for heap overflows and do quite specific things that you wouldn't be able to do simplistically with a normal debugger. But there are some issues with using DTrace in this way as well. It's designed to be very production safe, which sounds like a good thing, and usually it is. But if you're using it for fuzzing or reverse engineering, not necessarily. Largely down to probe skips, which you can guard against by increasing the queue size and increasing how often it checks the queue. But if you do that, you sometimes lose the performance increase that you get from having them queued in the first place. And it's really designed for system administrators to be able to use this on a production system to troubleshoot and find things that are wrong with the... We're not being picked up. Okay, cool. So yeah, on a production system without interfering with the production system too much. It's also been found by people that have done more work with DTrace than me that it's harder to create a generic solution that will work for all programs that you can just throw at it and off you go. You're going to be placing a lot of probes, which can sometimes be a problem for probe skips and so on. So you very often have to tailor what you're doing to the specific process that you're investigating. And I really wanted to get something that was more generic that you could just quickly get up and running, and then possibly use DTrace later on or in addition to look for other specific things or to investigate the process further in a quicker or more efficient way. And of course, we can do most of this stuff anyway, and a lot of people are doing it anyway without DTrace on platforms that DTrace isn't available. So I really got to wondering whether DTrace was really the answer, and when we should use DTrace and when we shouldn't. And I'm not totally there with implementing DTrace in RSol. It basically is at the moment a debugger. But I can demonstrate from this that I've implemented the things that were being implemented with DTrace. You can implement them in this way as well. But as I say, I got to this point because I was originally just trying to get a process monitor for Sully, and then just realizing that, well, actually, I can do a lot more with this, and it's actually a really useful component to have. So what I want this to grow into is a suite that uses DTrace and debugging techniques interchangeably, so that you can experiment with them and use the appropriate method where you can. So what it is a library written in Ruby. And I emphasize it's a library because it's not a finished tool on its own that you can just go and run and it will do magical things. You can use it to implement tools that will do things like code coverage and process monitoring, etc. So this is a bit of an overview of the architecture. I'm not going to go into too much detail. You've got the core class RSol, which is what most people are going to use to make the key calls to do stuff. procfs is an important class. That's the interface to the proc file system. There's a few native extensions as well to get around some limitations of doing it in Ruby as opposed to a native compiled language. And this is a bit of an overview of the API, just to give you an idea. There's more stuff in there as well, but it just gives you a flavor of the kind of things that you can do with it.